Okay, good morning, students. I'm back again with a new topic, that is velocity. So, yesterday or in the previous video, we talked about speed and what we had already studied in the previous classes, that is class 7 and 6 as well. But the new thing that we studied was speed and uniform speed. We also studied if the object is moving with uniform speed, then the object is also moving in uniform motion. We talked about this. But before that, we also studied a very important topic, that was scalar and vector quantity. So what was scalar and vector quantity? Scalar and vector quantities were the quantities in which we only had magnitude. That means just a number describing them. That means if somebody's mass is 30 kg or 40 kg, then that number is the scalar quantity. That number is magnitude. The vector quantity is the physical quantity which has a magnitude as well as the direction for its description. So we talked about speed, and we also said that it has no direction, just the distance traveled in certain amount of time. And we know that distance is actually a scalar quantity. What is speed? Speed, it is distance traveled in certain amount of time. And what is distance? Distance is a scalar quantity. So now we move on to velocity. Velocity is similar to speed with only one tiny difference, that is velocity is displacement of an object. It is displacement of an object in certain amount of time. In certain amount of time. That means that for speed we had distance and for velocity we have displacement. So we talked about displacement. Displacement is actually the shortest distance from point A to point B, and that is known as displacement. So the shortest distance from point A to point B is called displacement. So if we talk about velocity, then it is displacement of an object, not distance. It is displacement of an object in certain amount of time, or if we can say that it is speed of an object with a direction. So how can this be described? Let's say that if an object is moving from point A to point B and its path is not straight, then the object is covering distance. But let's say another case, point C and D, where the path or the road is also a straight line. So in this case CD, distance and displacement are same. In the first case, A and B, the path is not straight, so A and B we have distance and displacement which are different. But in the second case, point C to point D, distance and displacement are same because C to D, it is a straight line. So the distance of an object is similar to displacement because the path is a straight line. And when it is a straight line, we can describe a direction. So even in this point A and B, we can describe the displacement which is a straight line. So displacement upon time is known as velocity. So it is given by the symbol V, and we write displacement as s upon time taken. Now remember, we had s as speed as well, but from now onwards we will talk less about speed and more about velocity. And in case of velocity, V is velocity and s is displacement, not speed. I repeat, s is displacement and not speed. So velocity is displacement upon time taken. In previous case, s was speed, but we are not talking about that anymore. Whenever we are talking about speed, we will talk about velocity. So velocity is displacement upon time taken, which is the same formula as speed is equal to distance upon time, but now we have velocity is equal to displacement upon time taken. Is it clear? I hope it is. Now let's move forward. Just like we talked about speed, we will also talk about uniform velocity and non-uniform velocity. So what is uniform velocity? So if the object is moving in if the object is moving in a straight line with while covering equal displacement in equal intervals of time, then object is moving with uniform velocity. I repeat the whole definition. If the object is moving in a straight line while covering equal displacement in equal intervals of time, then the object is moving with uniform velocity. It is similar to that we talked about uniform speed. It covers equal distance in equal intervals of time, then the object is moving with a uniform velocity. Over here it is the same uniform speed. Over here it is the same thing. Instead of distance we are writing displacement. And once again, if the object is moving with if the object is moving with uniform velocity, then it is also in uniform motion. I repeat once again, if the object is moving with uniform velocity, then it is also in uniform motion. I hope it is understood, students. Let's move forward once again to similar topic, that is non-uniform velocity. So if you remember, we talked about uniform speed and non-uniform speed. We talked about the same thing. If the object is moving in uniform motion, then it is in uniform velocity or constant speed. Over here it is the same thing. If the object is covering equal distance and equal displacement in equal intervals of time, then the object is moving with uniform velocity. And if the object is in uniform velocity, then it is in uniform motion. So the same thing is over here. If the object is not covering equal displacement in equal intervals of time, then it is moving with non-uniform velocity. It's simple. Now we talked about a similar topic, but what can also be known as average velocity. What is average velocity? Average velocity is described as total displacement upon total time. What does this mean? It means that suppose an object is moving from point A to point B. Obviously it is displacement, that is why we are describing it with a straight line. So object is moving from point A to point B, and his velocity is not uniform, or he is not in uniform motion. So suppose from point A, at some point over here, his velocity is different, or you can say he is not covering equal distances, or he is not in uniform motion. So let's say over here he covered 10 meters in 5 seconds, and in 10 seconds, so we are talking about equal intervals, 5 seconds, 5 seconds, over here it is 15 seconds, again 5 seconds, over here it is 20 seconds, once again 5 seconds. But the object is not covering equal displacement. So over here 10 meters, then over here let's say 20 meters, but in the next one he is only covering 25 meters. After that, let's say 40 meters. So in the first case the displacement was 10 meters. The second case, once again 20 minus 10, it is 10 meters. In third, 25 minus 20, so it is 5 meters. In the fourth, 40 minus 25, so 15 meters. So in all the cases the displacement is uneven, so it is non-uniform. So if the displacement is non-uniform, then you don't have to find individual, because the velocity is not uniform. So what you find? You find average velocity. And what you do? You take the total distance. Let's say that the object covered 100 meters in 60 seconds. Then you find the total average velocity as total displacement, that is 100 meters divided by 60 seconds. And what you get, the answer is as 5 by 3. 2 5s are 10, 2 3s are 6. So what you get, the answer as 5 by 3 meters per second. I hope it is clear to you. This is average velocity. In other case, we can also find, let's say that point A and point B over here, an object is moving before it reaches point A. So it is coming from some other point, and at this point, when I find the velocity, when it reaches point A, I am observing at this point. But the object is already moving and it passes through point A. So let's say its velocity over here is 25 meters per second. And then this is its final point, and when it reaches over here, its velocity is 40 meters per second. And in between, the total time it takes is, let's say, 30 seconds. It is taking total time as 30 seconds. Then how do you find average velocity? So average velocity can once again be found out with a simple formula. We take its initial velocity. What was its starting velocity? 25. And then final velocity, that is 40, upon total time, that is 30 seconds. So it can also be taken as initial velocity plus final velocity upon total time. So this can also be taken as initial velocity and final velocity upon total time. I hope it is clear to you. Is it clear? Okay. We move forward and we talk about a small topic, that is instantaneous velocity. What is this instantaneous velocity? Instantaneous velocity is simply defined as velocity of an object at a simple point or at a certain point. Suppose an object is already moving and we take a certain instant of time, let's say after 25 seconds. At this point, whatever the velocity of the object is known as its instantaneous velocity. I repeat once again, what is instantaneous velocity? Instantaneous velocity is the velocity of an object at a certain point or a certain instant. So let's say at a certain instant of 25 seconds, what is the velocity at that point? Then at that point, the velocity is known as instantaneous velocity at that instant, at that particular point. Okay students, we revise once again what are the different topics that we studied today. We mainly studied just one point, that is uniform velocity. What is velocity? Velocity is the displacement of an object in a certain amount of time. Displacement of an object is certain amount of time, or we can describe it as speed of an object with a certain direction. Okay, I can give you one more example related to this. The vehicles. In our vehicles, we see the speedometer. Let's say that the car or a bike is moving with 40 kilometers per hour. That speedometer that shows us the speed of the car or a bike is actually giving us the speed, because it does not describe the direction, because the speedometer does not know which direction the car is moving. It does not care. It only shows us the speed of an object, whether you are taking a turn or not. So it does not care which direction it is. The speedometer always indicates the speed. It does not indicate the velocity. In the same way, odometer, we have odometer in the vehicles that shows us how many kilometers it has already done. Let's say 4,000 kilometers a vehicle has already gone, or it has traveled 4,000 kilometers. This 4,000 kilometers shows us the total path it has walked through. It does not care which direction, because in the morning you move from a point A and you take your car or a bike and come back to the same point, and still the vehicle has covered a certain distance. So the initial and final point is same, but it has covered certain distance, and that odometer shows us the total distance traveled and not the displacement. I hope this simple example of the vehicles will make you clear the difference between distance and displacement. Have a good day. We'll talk about in the next video.